Okay, for this video, we'll go on to the next step, which is to estimate the ARDL model. Now, ARDL requires that the variables are stationary. So what we have to do is to use stationary data to estimate. Now, let's go ahead and uh, share the screen. Share. Okay. Estimate ARDL. Now, in the previous video, we showed that for our data on stock price and Dow Jones Industrial, as well as bond, uh, the variables are difference stationary. That means that we have to take the first difference and estimate the ARDL based on that um, first difference. Okay. So in your case, your variable may be stationary already, or your variable may be trend stationary, right? So what you're going to do is to use the variable based uh, after the transformation to make it stationary, okay? If it's trend stationary, you include the t variable in the regression. Okay, so I think for the most part, everyone is going to have different stationarity, okay? So let me show you the example for different stationary data. We're going to estimate the ARDL model. First, we're going to decide variable transformation. In my case, my variable transformation is going to be first difference. Okay. In your case, it may be the trend. We'll deal with that later, but we'll deal with the case where we have first difference. Okay. I'll deal with that in the next video. So for my case, I'm going to use first difference for all my variables. Okay. Uh, like here, for my case, it's going to be this one. For trend stationary, you're going to have a trend in the model. Okay. Estimate ARDL model. I'm going to do just, one lag for all variables to keep it simple. So the way we're going to do that is if you don't have the command already, type this. You're going to go and ask to download the ARDL package. Okay. ARDL. In my case, I already have the package. Autoregressive distributed lag regression model. Okay. There it is. All right. So close that. In my case, I'm going to do ARDL, and my Amazon price is the dependent variable, and it's going to be explained by DGIA scaled and T-bond scaled. Okay. And I'm going to specify, okay, first I'm going to do it like this. Here's the thing. I don't specify anything, right, in terms of lags and all that, but the program is going to choose for me using AIC criteria. Okay. So in this case, look, it chooses this regression, ARDL, 1 for Amazon price, lag 1 for DGIA scaled, but 0, meaning no lag values for T-bond scaled. So what you're going to see is that you're going to have price variable lag 1 here. DGIA scaled, we have current, and then you're going to have lag, right? And T-bond scaled is going to have no lags. Right? Let's interpret this a little bit. For the Amazon price L1, this is as we've seen before, right? Price in last period goes up 1 unit. Current period price goes up 0.84. Significant. DGIA scaled, GGIA scale goes up 1 unit right now. Amazon price is going to go up 0.4. Yeah. Significant. DJIA scale goes up by 1 unit. Last period, Amazon price is actually going to go down 0.25 this period. So it seems that the lag effect of DJIA stock is going to push down the Amazon stock price. This is significant as well. P-value 0.029, meaning the chance of making a mistake is 2.9%. For T-bond scale, actually this variable is negative, but it's not significant. Okay, so that's your ARDL. Right? Now, in the lab exercise, I asked you to keep things interesting. I want you to use lag 1 for all the variables. Okay, instead of using the default from Stata, I'm going to use lag equal 1. And that's done by including the option lag 1 here. Okay, first difference. Okay, ARDL 111. And here are your estimates. Actually, with lag 1, I have better results for T-bond. Current T-bond price actually when it goes up, it reduces Amazon price by 10 cents, right? This is the p-value 0.07, so this is significant at 10%, right? Because right now the chance of making a mistake is 7%, so it's acceptable at the chance of 10%. Okay, so that's your ARDL model. Okay. And the next thing just for you to report, including the stars and asterisks and all that stuff. So I think I have to change a little bit here. In this case, well, I can use this as an example. In this case, I have SET bond and stock price T minus 1. Yeah, so just put the significance, the star next to either the variable or next to the coefficient. Okay, so that's it for this video. Oh yeah, what if your data is trend stationary? What if your data is trend stationary? So we're gonna do ARDL. Okay, same thing, but you include the trend option. Okay, this is going to adjust for the trend issue. Okay, now this one sorry, this one shoot, it uses the AIC criteria to go 110. There's my results, right? A little bit different. Remember that because your variables here are not trend stationary, right? Running this, even though you adjust for the trend, is actually going to be spurious, right? These results you see is going to be driven by some coincidental factors, right? So but this is going to be right if your data is trend stationary. Okay. All right. So finally, remember that our data, we saw that it's not stationary. So that running ARDL is going to give us spurious results. So what we have to do is to actually use the first difference of each of these variables. So we're going to put D dot instead. We're going to transform these as first difference. Okay. And we're going to specify one lag. Okay, never mind. So I'm going to have to generate gen gen d Amazon equals d dot Amazon. Okay. I'm gonna gen d underscore t bond equals d dot t bond gen d djia equals d dot djia. Okay, now t bond, the one I used here is actually the scaled one. Okay, the under lowercase one. So djia scale, same here. Okay, I'm gonna run ardl. Okay, I'm gonna have the Amazon as a function of djia and dt bond. I'm going to specify lag 1. Enter. Oh, no, not d dot, sorry. Mm, There. The Amazon, ddjia, dt bond. Enter. And there's my result. Okay, not spurious anymore. Lag change in Amazon price doesn't do anything to current price change. Now, if DJIA goes up, it's gonna increase the price of Amazon by 0.25, and the lag of Dow Jones Index doesn't affect Amazon price because the p-value is not significant. T-bond, okay, shows a negative effect on Amazon price. T-bond yield goes up, Amazon price goes down, negative 0.111. This is significant at the 10% level, right? So now this estimate here is no longer spurious compared to previously when we just estimate the uh, model without adjusting, okay? Before it was going down point negative 100, it was spurious. There was some things going on that makes this number different from what it should be, okay, for the T-bond part. Once we control for the spuriousness, by taking first difference, this is the new result, okay? This is how the price of Amazon stock actually responds to bond price. Okay, so you should have enough here, report, and then we're done, right? For the lab, you're gonna be done once you have all these. Insert page number, bottom page. Okay, stop it. All right, so that would be all. And I guess any problems you have, just write comments or say it in class and we'll answer your questions.